Good evening, team. Hope I'm audible to you all.
Yes.
Thank you,
Good
sir.
evening. Yeah.
Happy to invite you all for the final day of machine learning workshop. Actually, Kartia ma'am is having an important meeting today, so she'll be joining at the end of the session. Before that, we'll go for the prayer as usual, and Sujit will continue the session. Hope my screen is visible to you all. Can someone volunteer to do the prayer today? Yes, can someone volunteer?
Myself,
Yeah, yes, ma'am. Please proceed, ma'am.
dear God, I place my humble needs before you. My need to meet my responsibilities in the world. My need to use my God given talents and abilities. My need to fulfill my place here on earth. I pray for your guidance now to show me the way to the perfect opportunity to do what I love, to do what I can do well, and what will fulfill my needs mentally, spiritually, and financially. Help us to walk in faith thus you show us the way. I am praying for everyone in the universe. Let them feel safe, happy, peaceful, and healthy. Thank you, God. Thank you.
Thank you, ma'am. Sujit Kumar, you can take over the session.
Thank you, Lou. Thank you so much. Okay, all. Good evening once again. For the final day of this workshop, I welcome you all. Right. So let us not waste much time. We'll directly move on to what has to be discussed today. So hope my screen is visible. Give me a minute. Yeah, thank you, sir. Give me a minute. Yeah, so we are good to go now. Yesterday we have been discussing about gradient descent, right? So we have discussed why we are going for gradient in order to find out the minimum of any function, right? So when you want to find out the minimum or maximum of any function, you have to find out the gradient of that particular function. So in this case, we are trying to find out the point at which the cost function is minimum, because the cost function is what we call as error. So we have to find out a point where the cost function is going to be minimum. That is this particular point. That point is your optimum weight, right? So the weight at this particular point, theta x, is what your optimum weight is. This theta x can be some mx and cx, right? So this should be your optimum weight, the weight at which the cost function is minimum actually, right? Okay. So to minimize the cost function, we have to take the gradient. That is why this algorithm is called gradient descent. Gradient is the first derivative, right? And we have to equate it to 0, we'll get the weights. But there is a standard equation pertaining this gradient descent algorithm. Okay, the equation goes like this. Guess what? Let us take theta as my weight. So the weights are basically m and c, the combination of m and c. But let us not make it two weight. Let us make only one, that is theta, right? Let us generalize it as theta. So I have j of theta, which is the cost function depending on theta, cost function depending on my weight. So this is going to be make up. In this case, there is an equation pertaining to this curve. That equation is, so theta is your weight, right? New weight is actually equal to the old weight minus alpha times the gradient. This is the equation for gradient descent. I'll explain what it is. Okay. So the new weight is going to be the old weight minus this is the new weight. So new weight, what you have to update to your equation. Let us call y equal to theta 1x plus theta naught, right? Or mx plus c. Whatever you the way you take, that is same. Mx plus c or theta 1 x plus theta naught. The weights. So the new weight is going to be the old weight minus alpha times the gradient. I'll explain what it is. You please listen carefully, right? Okay, so what is basically the gradient? First of all, if I have a curve like this, let us say I am finding out the differentiation of this curve. Dy by dx. This curve is something y equal to f of x. I'm finding out the differentiation of this curve, right? And I can find out the differentiation at a particular point, right? That becomes my gradient, if I'm correct. The differentiation at a particular point will become my gradient, right? So if I differentiate, or if I take the differentiation at this point, can somebody tell me whether it will be negative or positive? Whether it will be negative or positive? If I take the differentiation of this curve at this point, so differentiation at some particular point x and y. Okay, I got an answer. Yes, people, different answers. All right. Any other answers? Okay. Yes, thank you, sir. One is correct. Thank you, sir. So it should be negative because anyway the curve is getting decreasing here, right? So the curve is decreased here, so it should be negative. If you differentiate at these points, at all these points, or on the left hand side of the curve, if you differentiate, the derivative will be negative. Definitely, the derivative will be negative, right? And in this point, you all very well know that the derivative will be 0, because anyway we are equating to 0 and we are attaining this point, right? So this point, at this minimum point, the derivative will be 0. And after that, on the right hand side of the curve, if I find out the derivative, what it will be? It will be positive or negative? On the right hand side of the curve, positive. Thank you, sir. Thank you so much. So this will be positive, right? Okay, so you just keep this in mind and follow me. All right. So the key takeaway from this slide is decreasing slope will have negative gradient, right? So on the left hand side of the curve, it will be negative. Right hand side of the curve, the gradient or the derivative will be positive. Gradient will be positive. You apply the same idea to it, right? So my idea is I have to reach this point where my theta is optimum, right? Where my theta is optimum, right? But initially, I will always start from a random point, right? I'll always start from a random point and I will reach the optimum point. Say, for example, let us say I'm at this weight. I'm at this initial weight. Okay, for which the cost function is this. This is my initial weight, let us call. Okay. At this point, can you tell me at this point, if I differentiate the cost function at this initial weight, what it will be? It will be negative or positive? At this point, if I differentiate the cost function, it will be negative or positive? How it can be positive? Just now I have told, right? On the left hand side of the curve, the derivatives must be negative. Is it okay, ma'am? Yes. Thank you. So at this point, you are starting from any initial weight, right? At that point, the cost function is negative in this point, left hand side. If you put a negative weight here, a negative derivative here, this equation will become what? Negative plus negative. So the weight will get incremented, right? The old weight will get added up. So the weight will get incremented, right? You are getting my point, right? The weight will get incremented. Since there is already a minus here, we know minus into minus is plus. So the weight will get incremented. So you will automatically move towards a new weight. That means you will come here, right? You will come at this point. You will automatically increase the weight. So your new weight somewhat here, right? Your new weight will be here. At this point, I'll again calculate the gradient. Can you tell me what will be my gradient, negative or positive? Negative. So again, you substitute that negative gradient in this, you will again get increased weights, right? The weight will get increased, right? Because if you substitute a negative value here, since you already have a minus, the weight will get incremented. The weight will be theta old plus some value, right? So again, you will move towards this direction. So again, you will come here. So the cost function gets minimized. This is how gradient descent works. So again, you eventually you'll reach this optimum point by keep on doing this. Eventually reach this optimum point. But after that, if you simply increase your weights, let us say I'm starting from this position. Okay, this is how it works. If I start from this position, if this is my initial weight, this is how I approach the optimum point. This is how we approach the optimum point. I'll take the gradient, it will be negative. So I'll keep on adding the weights. I'll reach the optimum point eventually. But what if I start here? What if I start in this? Okay, let me show you. I'm sorry. I'm sorry, people. I don't know why it happened. All right. What if I start at the right-hand side of the curve? Let me ask you in this manner. My initial weight is on the right-hand side of the curve. What will be the derivative of the cost function? Yeah, positive. Thank you. So if you have a positive gradient, what will happen to your weights? What will happen to your weights? Oh, sorry for crashing. Okay, not an issue. Yes, the weights will get decreased. So what I'm trying to confess here is, if I start from this, follow the black color. If I start from this initial point, here if I take the gradient, that will be positive, right? That will be positive. So if you substitute a positive gradient here, your weight will get decremented. So it has a minus, right? Your weight will get decremented. So eventually I've started here, okay? But you will move in this direction. Your weight will get decremented, okay? So irrespective of wherever you start, you will eventually reach the optimum position because of this equation. You will eventually reach the optimum position because of this equation. Am I making it clear? Is it okay? Is it okay? Is it okay for everyone? Yes, yes. Okay, fine. Is it unambiguous or? Yeah, okay. All right. So that's how gradient descent works. So just to remember this equation. And this factor is there, no, alpha. That is not actually the step size of the step you have to make. For example, I'm here, I have to move here. Let us say this point is A, this point is B. So from here, I have to move here from A to B. How long I have to move, how long I have to increment the weight. That is determined by alpha, right? That is determined by alpha, and that is again, it cannot be too more, it cannot be too less. You should have an optimum value for alpha itself. That is called as a hyperparameter. Okay. A hyperparameter is something you should fix before the training. You should fix before all these processes, right? When I call hyperparameter, I have to fix that parameter before the training starts, and that should not be affected by the training process. After the training also, the hyperparameter should have the same value. That should not be affected by the training process, right? That is what I mean by hyperparameters. Fixing something before training, before the learning process, that remains the same after the learning process itself. So that is your hyperparameter. Alpha is a kind of hyperparameter, that is a learning rate. Okay, learning how the rate at which you reach the optimum position, the rate at which you reach the optimum position, right? Okay, so that is what linear regression is all about. So to summarize with, in linear regression, to the data set, we are actually trying to fit a line of best fit. Okay, we are actually trying to fit a line of best fit. The line of best fit is determined by having a minimum error, right? Minimum error. The error must be minimum. Okay, and this minimum MSE, that's the mean squared error, is actually called as the cost function, which depends on your weights, can be m comma c or theta, whatever it is. The ultimate objective is to minimize this. Ultimate objective is to minimize this. The line which has the minimum cost function should be the line of best fit to your data set. Getting it right? So to minimize this cost function, we have to use an optimization algorithm. That optimization algorithm is stochastic gradient descent. Okay, so why it is called as stochastic, because I can start from any random point, right? That's the randomness. For example, if this is my curve, the learning curve, so j of theta and theta, I can start from here, or I can start from here, I can start from here. Eventually, I'll reach this optimum point. Because if I start from the left-hand side of the curve, the weights will get incremented and I will reach the optimum point. If I start from the right-hand side of the curve, the weights will get decremented and I will reach the optimum point. Anyway, that is going to happen, right? Okay. The learning rate alpha has to play a good role here, but that I wanted to skip because time is too less for us. I have to cover some other algorithms also. So for time being, I'm skipping that. Okay, is linear regression fine? Is it okay? Shall we move on to some other algorithms? Yes. Yes. Thank you, gentlemen. Thank you. So we have seen one regression algorithm, right? So regression, if you fit a straight line to the data points, that becomes your linear regression. That the equation is constant, y equal to mx plus c, and you are going to vary only this m and c. You are going to attain a particular m and c for which the cost function is minimum. That is what I keep on repeating. And if you, instead of fitting a straight line, if you can even fit a parabolic curve, because in real world you cannot expect all the data to be linear, right? Some other non-linearity you could see in the data. Okay, for example, if this is my x-axis and y-axis, you could see some curviness in the data. Okay, so in that case, it is better to fit a polynomial rather than fitting a straight line, right? It is better to fit a polynomial rather than fitting a straight line, right? And again, the equation of polynomial is exactly, sir, thank you, y equal to ax square plus bx plus c. If this is the case, if I change a, b, and c, those are my weights. If I change a, b, and c, I'm going to get different polynomials, right? I'm going to get different curves. In that, what is the polynomial of best fit? What is the particular value of a, b, c for which again the cost function is minimum? Again, the cost function or error is minimum, right? For this, again, you have to use gradient descent only. That process remains the same, except the fact that you have to update these three parameters, a, b, c. Okay. R squared error, I guess I won't be able to cover. Time is too short for me, sir. R squared, those are some metrics, right? Regression metrics. Yes, so polynomial regression. If you want, you can fit a logarithmic curve also. That becomes a logarithmic regression. Y equal to a plus b log x. So y depends on log of x. This becomes logarithmic regression. So in this case, your weights are a and b. If you change a and b, you will get different logarithmic curves, among which is your best fit, and that can be found out by finding out a particular a and b for which this cost function is minimum, the error is minimum, right? Okay, so you can based on the curve what you are fitting, you can have different or several regression algorithms, and which algorithm to choose, that depends on your data set. You have to plot and see the nature of the data set. If the dependency is linear, you can very well fit a straight line. Or there is one way, you can try all the regression algorithms and you can see which produces the minimum error, and that you can fix it, right? Yes. So now we will see a classification algorithm. So far what we have seen is regression, right? So from the by fitting a line, we'll arrive at an equation. Okay, once you have got that equation y equal to mx plus c, you can simply substitute any x value to get a y value. Once you have got an equation, nothing is unknown, right? Everything becomes known now. You substitute any x value, you will get a y value. That's all. That's prediction, right? So that's a continuum of values. Now we will see one classification algorithm. Before that, let me ask you a question. Can I use linear regression for classification? Because the idea is I've used the linear regression for regression problem. That means I'll fit a straight line and I'll extend that straight line in order to predict the values. Now I'll ask you this question. Can I use linear regression for classification? No. I got an answer, no. No. Okay, people are saying no. Please take a minute to think about it. Okay, so I couldn't see any more responses. That's fine. Okay, let me tell you the explanation first of all. Then you yourself can decide whether you can use linear regression for classification or not. Right. So if we build a classification model, the output what we can expect from the classification model is see, it has to produce either 0 or 1 if it is a binary classification problem, right? So for example, if I can build a dog cat classification problem, given a picture, it has to say whether the animal is either dog or cat. Okay, and the classification will always have some confidence. Okay, exactly. So that's what I'm going to talk about. Give me a minute, right? So the classification is going to, the output is going to be accompanied with confidence, right? So along the output, you will get the confidence value also. That shows how much the output is cat and how much the output is dog. So it is always having some confidence, which you can clearly see in any object detection algorithm if you have built it already, right? So that confidence level is very important. Okay, so yes, so if that is the case, let us take one feature. Okay, let us take a very simple example. Study hours, right? Number of hours I study. A very simple example. Number of hours I study and the probability of getting pass. Okay, number of hours I study and the probability of getting pass. Okay, so the output is either 0 or 1, right? The output is definitely 0 or 1. Okay, so number of hours I study, let us assume one threshold. If I study less than 5 hours, I will get failed, and if I study more than 5 hours, I'll get passed. Okay, you could include more features. Okay, but that is not visualizable, right? Only if I have a 2-dimension, I can visualize it using this graph, right? So if I study less than 5 hours, I will get failed. So those points will lie here. Okay, those points will lie here. This stands for fail. Okay, and if I study more than 5 hours, I will get passed. So pass means 1, right? So it can be either 0 or 1. That's all. It can be either 0 or 1. So this is pass points, right? But is there any problem if I fit a straight line here? That means if I apply linear regression here, can you see any problem here? If I fit a straight line to this data points, is there any problem that you could see? More number of outliers, yeah, that could be one potential problem. Errors more, yeah, that could be one potential problem as well, ma'am. Any other very straightforward problem? A very direct, you just look at the y-axis. I'll give you a clue. Look at the y-axis. What is y-axis? Probability of getting pass. Okay, so that poor accuracy, yeah, okay, eventually your accuracy will get affected. I agree with that. Is that you just look at the y-axis and tell me why I couldn't fit a straight line here? A simple rule is there, a very simple rule, which we all might have studied in our school days. Yeah, ma'am, that's fine. So the idea here is, I have a probability here, right? Probability of getting pass. Okay, I have a very simple rule. Probability must lie between 0 and 1, right? This is one kind of a very simple rule. Probability should not be greater than 1, should not be lesser than 0, right? So here you can see if I keep on extending this line, that rule won't work, right? So eventually you are doing something wrong. Okay, so if I keep on extending this line, this rule won't be actually applicable. So in this case, linear regression failed. There is one more problem that is pointed out by Muhammad Ishaq. Thank you, sir. So the idea here is, if I have an outlier here, what will happen to my line of best fit? So let us say that outlier is not removed. By some point, the outlier is not removed. What will happen to my line of best fit? The line of best fit will be actually looking like this, right? Because I'll try to cover that point also. In that case, this rule will fail, because even though I got, so let us say this is my threshold point. Even though I study for 8 hours, I will still get failed, as you can see, because I'm less than threshold level. So even though I study for 8 hours, I'll still get failed. My line of best fit will get shifted like this. And if I have an outlier here, again, it will be shifted towards this. So it is prone to errors. That is one important problem, right? So there are two issues here. If I try to fit a straight line, probability will get affected. So you cannot have something like that. And the line of best fit won't be suffice. Okay, if you have outliers, definitely this won't work. Accuracy will be less. Again, thanks, Mr. Irshad. You are right. Accuracy will be less here. Is it convincing why you couldn't fit a straight line to a classification problem? Is it okay? Yes. Okay. So now, so one thing what we have to do actually. So what is the change that I have to do for the line of best fit? So let us say I'm fitting a straight line only. That is not a confusion. I'm fitting a straight line only. Right. So this is 1 and this is 0. Right. So if I fit a straight line here, what is the thing I have to do to attain this rule? V of x is less. Let us not care about outliers. Okay. To attain this rule, what is the thing I have to do here to attain this rule? You can look at the straight line and tell me. So it should not be lesser than 0. It should not be greater than 1. That's the idea. But the line keeps on extending. So what should I do here? Any idea? The line will keep on extending like this. Yes, exactly. You have to restrict. You have to basically restrict. Okay, wow. So in that case, what you have to do is you have to bring the line. So you have to make something like this. For every value which is greater than this, it should be 1 only. The line should not keep on growing. And here also, the line should not keep on growing like this. You have to bring this and you have to restrict. So eventually, you have to attain a shape like this. You have to attain a shape like this. So it should be 1 for all the values and it should be 0. And you should have a line here. Is it okay now? Am I making sense? Is it okay? Understandable? Yes. Okay. So if that is the case, I have to use some other function, not a straight line, definitely. I have to use a function which has the shape like this. And this function is what is meant as sigmoid, not step, actually sigmoid, which will have a shape like this. Okay. So for a sigmoid function, you put any x value. The output will be at most 1. That is what you have to note it down. So the sigmoid function is actually given by this equation, y equal to 1 plus e power minus x. Right. Okay. So here what we have to do is, it is okay if you are fitting a straight line. Is it okay? It is actually okay if you fit a straight line. After fitting a straight line, you apply the sigmoid activation function too. Right? You apply the sigmoid activation function too, so that the line will be restricted. The line will be restricted. So the process for a classification problem, after performing linear regression, that means after performing linear regression, after fitting a straight line, you have to apply this sigmoid activation function. You have to apply this sigmoid activation function. You have one more block, that's all, right? And together, this entire block is called as what? It's called as together they are called as, this algorithm is called as, I think I got the answer already. Yes, logistic regression. Thank you. Logistic regression. So this is what we mean by logistic regression. Even though it is named as regression, it is used for classification problem, right? It is used for classification problem. The name might mislead you, but it is actually used for classification problem. So in logistic regression, you take linear regression and followed by a sigmoid activation function. So just by changing the activation function, I can decide whether I'm going to regress or I'm going to classify. That's the beauty of machine learning. Okay, so that is the importance of any activation function. Just by changing the activation function, if I remove this, this becomes a regression problem. If I include this, this becomes a classification problem, right? Okay, is it okay? So I have seen one regression algorithm and one classification algorithm. Yes, yes, okay. Right, so thank you, sir. Fine, we'll see one more algorithm which is common for both regression and classification. Using this algorithm, you can perform both regression and classification. That algorithm, very important algorithm, KNN, K nearest neighbors. Okay, K nearest neighbors. Fine. So K nearest neighbors, it is basically a proximity based classification algorithm. They will say, mostly they will say proximity based classification, right? So I'll tell you what it is. Let us say I have one, let us take an example and we'll do this. Okay. Let us take a classification model which will classify either it is a bike or car. Okay. Let us say a classification problem, we will classify it as whether bike or car. Okay. So let us take two features. In the y-axis also, we'll take one more feature. Okay. We'll take one more feature. Mind you, that is not the output, that is a feature. Okay. So size and mileage. So eventually, your size will be low, but mileage will be high for a bike. So your points will lie here. And your size will be more and mileage will be less for a car. So those points will lie here. Those points will lie. Let us call car as O. Okay. So this is O, this is X. This diagram is called as a classification diagram or a classification space. If you plot the data set, this is what it looks like, right? So if you have low size and high mileage, that means it is a bike. If you have a very large structure, right? So the size will be large and the mileage will be low, means then that should be a car. Okay, it is basically a feature-based classification, not an image-based classification, right? Okay, so this is that. This is a classification diagram, right? The idea here is, let us say this is what is given to an ML model. I want the ML model to learn this. Listen carefully, please listen carefully. Okay, let us say I have an unknown sample here. For which I don't know what it is, whether it is a bike or car. Can you tell me whether it is bike or car? Can you guess, make a guess? Yes, bike. Okay, thank you. So since mileage is low and size is low and mileage is high, it must be bike. So how it will identify, it will select K nearest neighbors. That K value is what fixed by you. That should be fixed by you. So that is K nearest neighbors. If I take K as 3, it will take 3 nearest neighbors. That means the distance from it should be less. Okay. So the three nearest neighbors are this point, and this point, right? Three nearest neighbors it will take. So since all these three neighbors are bikes, you have to perform voting now. The first step is to find out three nearest neighbors based on the distance. Okay, that's what I told you before. It's a proximity based classification, distance based classification, right? So you have to take the distance, Euclidean distance from that point to all the points, and you have to choose 3 points. If I fix k as 3, you have to choose 3 points for which the distance is minimum. So after choosing those 3 points, you have to perform a voting, right? Since all these 3 points are green in color or bike, all these 3 points are bikes, so this point must also be a bike, right? This point must also be a bike. I'll give you one more example, right? Let us have something like this. Let us say I'm taking a point here, right? Let us take, I'm taking a point here, and I'm again taking 3 nearest neighbor. Let us assume that this, and this, these are my 3 nearest neighbors, right? These are my 3 nearest neighbor. That means 1x and 2 O's. So I got 1x and 2 O's, right? If I perform voting, can you tell me whether my unknown sample is X or O? Can you tell me whether my unknown sample is X or O? If I have 2 O's and 1 X. O, basically, right? So that, because what if k is 4? That is what I have to talk about. Please wait. Right, so that should be O. Okay, so now this is what it becomes. So voting. Is what you have to take. See, this k value should always be an odd number. That is what we have to keep in mind. If we take a value like k equal to 4, if I take an even numbered value, what will happen? Can you tell me? If I take 4 different neighbors, any even number, what will happen? Tie. Thank you, sir. Thank you so much. So you will get a tie actually, right? So if I take 4 nearest neighbors, you get a tie actually. So you have an unknown point here. So if I take 4 nearest neighbors, this, these are my 4 nearest neighbors, right? 2x and 2o. So you will eventually get a tie. So in that case, you cannot decide odd. So k value, you better take it as an odd number. Okay, but it is not always necessary. Okay, but better take it as an odd number to avoid ties. Is that fine, Rishad sir? Is that fine? Okay, so right. So basically, I have to fix the k value before the training. Okay, before the training, I have to fix one k value. Yes, sir. There are different solutions. You can tweak on the distance function what you are using. So basically, what I'm using here is Euclidean distance, sir. Actually, let us say these are my points, and this is an unknown sample. What I'm taking the distance, right? Distance from the unknown point and the known point. This distance is actually a Euclidean distance. You know that, right? X2 minus x1 the whole square, y2 minus y1 the whole square. You can take some other distance functions, something like a chessboard distance. Okay, Manhattan distance they will call it as. For that, this is your distance function. So even though your Euclidean distance gives you some points, the Manhattan distance should give you some other points, right? So in that case, tie can be avoided. This is one possible solution you can think of. Instead of using Euclidean distance, you can use Manhattan distance. This is Manhattan distance, right? But we fix it as Euclidean distance, so it is better if you take k value as an odd number. Definitely Euclidean distance, sir. Definitely. Centroid can be used. No, ma'am. Actually, centroid will be used in clustering, if I'm not wrong. Where you don't know which is X and which is O. You have certain data points which is unlabeled. In that case, you can use the centroids to form your clusters, to form groups, to group them. You can use centroids. Not used here, actually. How to decide the value of k? Swarup sir, actually, yes. So, but first of all, what do you call this k? I told you, I think I told you before. What do you call this k? K is something you should fix before the training. Then what do you call that? Yes, that is a good inference. Number of clusters, yeah, number of neighbors actually, number of not clusters, number of neighbors. There is no clustering involved here. Okay, there is no clustering here. You don't confuse this with k means clustering. That is different. That is unsupervised. This is no number of neighbors. I'm just picking the neighbors. I'm not forming any clusters. Is that okay, sir? Yes, thank you, sir. That is a hyperparameter actually. K is what you're fixing. That is a hyperparameter, and there is no mathematical way to fix the hyperparameter, right? Can I take k as 3 or k as 5 or k as 7? I don't know. It depends on the data set. You have to fix and take the results, and you have to look at the results only, right? So what I could say, a trial and error method. So you can fix the hyperparameters using trial and error methods only. And the process of fixing the hyperparameter, whether my k value is 3 or it can be 5 or it can be 7, which produces the least error, that you have to find out. You have to make a trial and run, and you have to find out which produces the least error. This process of fixing the particular hyperparameter is called as hyperparameter tuning. Hyperparameter tuning. Is that okay, people? What will be the largest for k that can be considered? Again, sir, that depends on your data set. Whatever you take in machine learning, that depends on your data set, definitely. So if you have a very larger amount of data, let us say I have 1 lakh samples, in that case, it is better to take k as 10,000 or 10,001 maybe. I have 1 lakh samples in my data set. Usually people won't take k as 10,000. It should be 3, 5, 7, 10. That's all. 7, 9, 11 or 13. For one project, I remember I had taken k to be 13 because that's a large data set. Amazon machine learning challenge, if I could remember. So they just gave the data set and directly from their website. So that data set was very huge, actually, 6.74 GB, if I could tell you. The Excel sheet, that's the Excel sheet with 6.74 GB. I couldn't open this in my computer. So for that, we tried. That's an ML challenge, open challenge given by Amazon. Okay. So for that itself, we have taken k as 13 only. So you just randomly take either 3, 5, or 7. 1 should be your optimum value. Mostly 3. Mostly 3 should be fine. Yeah. Okay. So that is k nearest neighbors. So KNN, we have used our classification, right? So we are classifying an unknown sample, whether it is X or O. But this can be used for regression also. So in regression, only one step has to be changed. Instead of performing voting, I have to take the mean values. I have to take the mean value of the neighbors. For example, I'll show you the data set. I'll show you directly in the data set. Okay. Okay, so let us take this data set. Let us say this sample is unknown. Let us say this sample is unknown. This sample is unknown. In that case, what you can do is you can take the nearest neighbors. Sir. If I take k as 3, these should be my nearest neighbors, right? These should be my nearest neighbors. You can just take the average of the nearest neighbors and you can tell the value here. So instead of taking voting, I am taking the mean value. That is where I can use KNN for regression. Okay, so KNN regressors have proved to be good, have proved to be better actually for most of your datasets because they are not functions, they are not linear, they are not polynomials, they are not logarithms, right? You are just finding out the average of the nearest values for an unknown value, right? So if I take 10.8 as my unknown value for which I don't know the value. I'll simply select the three nearest neighbors. I'll select the three nearest neighbors and I'll take the average and I'll put it here. So that's how KNN regressor works. Okay, there's no KNN regressor works. Again, I can give you 45 minutes to 1 hour explanation what I gave for linear regression. But since time being, I'm just brushing upon the algorithms. Is it okay? Is it convincing, the KNN regression? Yes. Okay. All right. Thank you, sir. Thank you so much. So that's how you do KNN regression. So till now, what we have seen is linear regression, logistic regression, and KNN regression. So I think it's high time that we should start the coding process, right? So if time permits, we'll see some more algorithms. So we can see SVM, decision tree regressors, and so on. So, but let us see a complete flow on the coding process. Then we will come back if time permits, right? I think these are the algorithms I thought I could discuss today. And so, yes, so I have 10 different steps which almost everyone have to keep in mind while building a machine learning model. Before that, I'll show you how to do the plotting. Okay, so let's take a new notebook. So what I'll do is, this session is for hands-on. I'll completely go through this entire notebook. I'll make you walk through this entire notebook. I'll explain each and every line of code. Then I'll give you a notebook which will have only questions, not the code. But I'll give you this notebook also. This notebook will have the entire code. You can copy paste the code. That is not a thing. But you have to know which code has to be copy pasted. That means whether I'm understanding the thing. That's what you have to self-evaluate. Yes, definitely. I'll share mine. I'll share all the notebooks, and I'll share one notebook which will have only the questions. You can use these notebooks in order to fill those answers. Okay. So that should give you a hands-on on machine learning. All right. So now I'll show you some examples for plotting. For that, for plotting, as I have imported this one, NumPy and Pandas, I have to import Matplotlib. Before that, let me import NumPy as NP, and let me import Matplotlib. I need not import the entire Matplotlib. Matplotlib is mathematics plotting library. I need not import everything. I have to import matplotlib.pyplot. So inside Matplotlib toolkit, I have a lot of submodules, right? Among them, I have to import only pyplot, is again a submodule, right? And that has to be imported as some keyword. Let me give the aliasing as PLT. That is what followed usually. Matplotlib.pyplot. So understand that Matplotlib is a very, very huge library. You have 3D plotting support as well, right? 3-dimensional plotting support as well. Recently, it has been introduced, right? So in that case, you have to pick one submodule, which is going to be pyplot, and you have to import that object only, right? You have to import that object only. So that should be a PLT. So let me import it like this. For every single line of word what I'm writing, I'll give you the explanation. Okay, so please listen carefully. The only thing I want you to have is a keen observation, right? So that you can follow it for the entire session. So PLT dot, so I got the object, right? I got the plotting object. So let me create some values so that can be plotted. So let me create an list maybe. Let me create some x values 1, 2, 3, 4, 5, right? Let me create some y values 1, 2, 3, 4, 5. Mind you, your x and y should be having same number of values, not the same value actually, same number of values. So it may not be same like this. It can be any value, but it should have same dimensions. It should have same number of values. Okay, wow. So now you got x and y. After that, you can plot x and y and see. So I can say plot x and y, plt.plot x comma y. So the syntax is plt.plot x comma y. Plt is the object what you have introduced or imported. Use that object to call a function which is called as plot, right? And you pass your x and y. This is what you will get. What you got is a continuous plot, right? It will automatically regress the values and it will print the plot. Okay, and you can label the x and y axis as well. Let us label the x label. So you can say plt.x label x, right? And plt.y label y. Let us call it y time being. And you can fix a title as well. Let us say plt.title random plot. I don't know what plot it is. I think it is a linear line, right? Straight line. So let me plot it a straight line. I mean, name it straight line. Okay. The syntax is pretty much similar to MATLAB. So if you have used MATLAB, this should be comfortable for you. Or you should be comfortable in this, right? Okay, so that's what I got x, y label, and the straight line is what the title I got. So this should be a straight line. If I want, I can plot a discrete plot as well. In that case, I'll just copy this code. Right, I'll copy this code. I'll just paste it here. Okay. So instead of plot, I can use a keyword or function called as scatter, which will give me a discrete plot. So which should look like this. So I got only 5 points in my data set, right? I got only 5 points. For 1, it is 10, 2, it is 20, 3, it is 20, 30, and 4, it is 40. So I got only 5 discrete points here. Okay, values will not be imputed, right? So I got 5 different points. If you try to use plot function, it will automatically join these points and make a curve. Okay, this is called as imputation. Okay, this is actually called as imputation of missing values. That is actually done by plot. But scatter won't do that. Scatter will plot only those points. Right? So that's the syntax for plot and scatter. So you have some other plots as well. If you could explore, you have box plot, histogram plot. Let me show you the histogram plot. That's very important. Let us say plt.hist pass the x only. So for histogram plot, it is not meaningful to pass both x and y, right? So what do you mean by an histogram plot? Actually, it will try to show you the frequency of values, right? So it will try to show you the count of values. So here in this array, all the values are actually occurring for one time. All the values are actually occurring for one time. One occurs for one time, 2 occurs once, 3 occurs once, 4 occurs once, and 5 occurs once. So that will be on the x-axis. 1, 2, 3, 4, 5, right? And they are all 1 only, as you can see in the y-axis. They are all 1 only. So all the values occurs for one time. So histogram must give you an idea of how many times a value occurs. Or in other words, you can use this histogram plot. One classical application is you can use this to find out the mode of your data, right? For example, I could have x value like this, right? If I take the histogram plot of x, and these plots are very, very helpful in showing the results. Okay, showing the results of what you got. You can include these plots in the research articles or papers what you are writing, right? So in this case, as you can see, we got an x value. Like I just assigned a random values to a list called x. Forget about it. And I got 3 ones in this list, right? 1 occurs for 3 times or thrice. So for one, this band, for 1, the value must be 3. The y value must be 3. So y-axis basically shows you the count of values. Okay, basically shows you the count of values, guys. Okay, so is it okay? These are plotting and they are very, very straightforward. You can easily do the plotting. You need not remember anything. Just remember this. You are passing x and y, that will get plotted. That's a. Is it okay? Shall we move on? Yes, thank you. And I'll show you one more plot, which is a very important plot. With that, we'll close this matplotlib. That is the distribution. That is very important. I could see these plots in many of the papers what I read. Okay, so that is distribution. Okay, for distribution, you have to use Seaborn SNS. Okay, that's again another library. Okay, that has dependencies with MATLAB, Matplotlib, but again another library for plotting. Import CBON as SNS. Okay. SNS dot distribution plot, dist plot, right? And I'll give the X, let us say, I'll give the X. That will show you the distribution of the array, what kind of distribution it is. So this is the distribution of your X. So the y-axis is the probability density function. Okay. So what you got is a distribution of the values. So you got a list here, right? X values. So if you want to know the distribution of this, you can say SNS dot plot of X. That should show you the distribution. You can simply take this plot and put it in your paper. Okay. Yeah, box plot is there. That is also possible. That should give you the skewness of the data, right? So I could say, if I'm not wrong, plt.boxplot. Okay, plt.boxplot, and that should be X. If it should show you the skewness of the data. So this data is pretty right skewed, not right skewed. This almost lies in the center, right? This is good actually. You have a normal distribution, but some data, maybe this line would be lying in this. In that case, you can say that the data is right skewed. Okay, that's a different concept in statistics, right? Skewing. Yes, you can see whether the data is skewed towards some point. Okay. For example, let me take one example and I'll show you that. Okay. Is there anything strange you can note here in this array? Is there anything strange that you can note here? Right skewed, exactly. So you see when you plot the box plot, okay, you see more number of threes. Okay, you see more number of threes. That means your distribution is not equal. Your distribution is not normal, right? You have three number of twos and three number of ones, but in this case you got more number of threes. So you are somewhat skewed towards that particular data, or I could say you are somewhat biased towards that particular number, right? Three. In this case, the machine learning will feel it difficult. The model will feel it difficult to learn because you have a few values of 2 and 1, and you have more values of 3, right? So the machine learning model will feel it difficult, right? So this data is actually right skewed. Okay, this data is actually right skewed, not right skewed actually. This lies here. So left skewed. So if you plot it, it is left skewed. This data is left skewed. Yes, I'm not confusing. This is definitely left skewed. Yes, so in that case, you can remove some of the values. Some of the values you can make it a symmetric distribution, right? So if you plot the distribution of this X, that won't be exactly a normal curve, a symmetric curve. It's SNS dot dist plot, right? Give me a minute. Okay. So this is somewhat you are getting a skewness here. A center should lie here. A center should lie here, but this is lying somewhat here. So this data is skewed actually. The center should lie here, but it is lying somewhat here. So this data is skewed. Okay, this data is skewed towards 3. I have more values of 3, so the distribution becomes skewed. Actually, you see that this line is actually your Q2 median. Okay, quartile 2 median. So this should lie here actually in the center, but it is somewhat lying here, right? So this is skewed. This is skewed. Is it okay? Is it understandable? Shall we move on? And again, that's a different concept I haven't included in the curriculum of this workshop, skewing. But since the people asked, I told you the answer. I gave some explanation. Okay, right. So it's 7:58 almost. So we'll take a break now. We'll come back at 8:10 and we'll continue coding. And I'll explain this notebook, and then you can write the code. That should be the proper way, right? See you again. Hello, people. Welcome you all once again to the last session of our workshop. Yes, so I think we are good to go. I think everyone is here. We'll start the coding part. Okay, so I'll show you one regression project, right? So which is a sample project. I'll explain the code. Please follow along with me, and you please stop me whenever something is ununderstandable, right? Something is not understandable. You can stop me. Okay, so yes, we'll do that. So the first step in building any ML model is, if you are not writing the algorithm on your own, if you are going to exploit some of the resources, you have to import all the libraries. Fine. So I have NumPy, Pandas, and Matplotlib are three basic libraries which you have to import by default. No other go, right? And right, so that should be there. And you have to read the dataset, right? You have to read the dataset. You have to use read Excel and read CSV function. So that can be used to read the dataset. Either it can be Excel sheet or a CSV format, right? After doing that, you can use head and tail functions to look at whether your dataset have been imported correctly or not. For that, you can use head or tail function, right? And after that, you have to plot and see the relationship between the variables, multiple variables in the data set. Univariate means you are taking a single variable, a single column, and you are plotting that. Best examples could be your box plot and distribution plot. Okay, those are univariate analysis. Bivariate is where you take two different columns, right? You take two different columns, any two columns, and you plot the relationship between them. That is bivariate. Okay, that becomes your bivariate analysis. And moving on to multivariate, you took multiple relationships, right? You took multiple columns and you plot them, right? Maybe 3 columns and 4 columns, and that becomes your multivariate. And then you have okay, so after doing that, you have to assign your X and Y. So you have the data set in your hand, you have done the plotting, you have made the analysis, you have to decide on which are your inputs and which should be your output, right? So that is what basically we will decide, right? Which should be my features and which should be my target, that you have to assign, right? And after that, I have to do a train test split. In that case, I have to split the entire data set into 2 different parts. One will be used for training and another one will be used for testing. The next step should be creating the ML model. Creating the ML model is like, you can simply make an object of the ML model that will be available in the library case. That's why you are importing libraries. If you import sklearn, this ML model will be there in the sklearn library. You can simply take it and create an object. After that, you can train the ML model by passing this X and Y, the train data. You can train the ML model. Afterwards, you can make the predictions, and there are some evaluation metrics which I will talk about, and that you can use to evaluate, or you can say whether your model is performing well or not, right? So that should be the flow. This is the flow of building any ML model. After that, you can go for deployment if you want. That is not covered in this course, definitely. That is pretty much simple. Yeah, you just have to know one more framework that you can so you can directly deploy an ML model into a website maybe, or even your mobile app you can build, and you can use it for real-time application. That is possible, but that is not covered in this course, to be very honest. Okay. Right, so first of all, I'll do this. I'll just follow these steps, right? The first step is to import all the libraries, right? So I'm importing all the libraries here, as you can clearly see. NumPy, Pandas, Matplotlib, and Seaborn, right? I'll import sklearn later. So let me import these basic libraries, and I have to use this syntax as well. Percentage Matplotlib inline. This will make your plot will to be saved in the notebook itself, right? So whenever I plot something, that plot will be saved in the notebook itself. That plot will be in line with the notebook. That's what you are mentioning by matplotlib inline, right? So the second step is to read the data set, right? So to read the data set is pretty straightforward. You can use read CSV, or if it is an Excel sheet, you can use read Excel. One thing what you have to note here is if you are using Google Colab, any questions? I could hear some voice. Any questions? All right. If not, then we will move on. So what you can do is you can go to this folder and you can upload your data set here. And remember, your data set will be deleted whenever you close this session, right? You can connect to our runtime. So I'm just connecting to our runtime. Please wait. Here you can see. You connect to our runtime. It will create a virtual instance of the cloud. Then you can upload it by clicking this button. So you just click this button and upload your data set. I click on salary. So you just locate that particular data set. This step should be followed if you are not using Anaconda distribution, that is Jupyter Notebook. Right. So locate the data set and you upload it. Okay. Okay. So always remember your uploaded file will get deleted when you refresh this. Okay. So once you have got the data set here, you have to click on this three dots here, as you can see. So click on this and just click on copy path. Okay, click on copy path. So that will give you the path of this data set. That path have to be pasted here. That's all. So I can paste the path here. I already pasted it down, as you can see. Pasted here. So that will be sufficient to read the data. That will be sufficient to read the data. Sometimes it may throw some errors. Sometimes it might feel difficult to read data. There are some other ways to tackle that. Now, as of now, it is better to use Jupyter Notebook if it throws an error, right? There is one more way. You can upload this dataset in your Google Drive, and you can mount the Google Drive in this folder. That can be done. You can look out for the possibility, right? Now, after that, you can say data.head to look whether the dataset has been imported correctly or not. So this is a salary data, right? I have only one feature and one target. That's all. And then let us do the univariate analysis. For univariate analysis, what you have to do is your y-axis should be a feature or a target. Y-axis should be a feature from the data. To take a single column from this data set, you can say data of year experience, right? Data of year experience. So that should give you that column. Data of year experience, right? And your x-axis, you must be wondering what is your x-axis. That must be simply the index. Okay. If you take year experience into your x-axis and salary to your y-axis, that becomes bivariate analysis, not univariate. Univariate means only one variable should be given importance. So in that case, I am taking my y-axis as x-axis as just index. X is index and y is actually the column, right? So this column. So I got a plot like this, which kept on increasing, something like this. Okay. And I could even plot the histogram plot, sns.hist plot or plt.hist. That should give me the histogram plot, right? Okay. Right. So I can even get the univariate analysis of salary. So what I have done here, the same scatter, I have just taken it down, and instead of year experience, I have given it as salary. That's all. So you should get a similar kind of plot because the salary also kept on increasing as we move over the data set. Now I can get the histogram plot of salary as well. That should not be a problem. It should be simple, right? Then if you want, you can get the skew values as well of each and every column. So for year experience, so whenever you want to pick one column, you have to use the syntax data of year experience, data of salary. That will take that one particular column as a panda series that we have seen yesterday, right? If you say dot skew, that must give you the skewness. So as you can see, the skewness is 0.379. It is okay if you have the skew between -1 to +1. Okay. Otherwise, you have to look around the data set and you have to pre-process a bit. Okay, it is allowed if you have a skewness between -1 to +1, that you have to verify. So simply by calling the skew function, you will get the skewness. Then for salary also, I got the skewness. So please understand, in the notebook, what I am going to give you, that will simply show you that you have to get the skewness of the column. So this is the code you have to use, right? You can either copy paste this code or you can type it. That's your wish, right? And I'm getting the count plot as well. This is for your experience. So then let us look at the bivariate analysis. In bivariate analysis, x-axis must be one column and y-axis must be another column. Luckily, I have only two columns in my data set. So let me take x-axis as your experience and y-axis as salary column. So I should get a plot like this. So by seeing this plot, the relationship between the input and output, can you please tell me which algorithm should I use for regression? By seeing this plot, can you please tell me which algorithm should I use for regression, for performing regression? Definitely linear, right? Because most of the data points are linearly increasing, right? So only by looking at the relationship, you have to arrive at the algorithm. Okay, you have to justify that I'm using linear regression. So it's very, very important that you plot. You can either use sns.scatterplot or plt.scatter. Both will do the same purpose. Okay, you can either use sns.scatterplot or plt.scatter. Use that syntax and give x and y. That's all. SNS Seaborn, sir. I think I discussed on this a while before the break. A Seaborn library. Import SNS Seaborn as SNS. All right. So correlation, a very, very important bivariate analysis, right? So correlation talks about the amount of relationship between any two variables, right? So correlation of x and y should talk about the relationship between them. You see the correlation here. The correlation should give you some value, right? So if that value is positive, that means you are having a positive correlation between x and y. So let us say the correlation of x and y, I got a value which is positive 1 point, let us say positive 0.85. That means since it's positive, what do we mean by a positive correlation value? You know, if I increase x, y will also increase. If I decrease x, y will also get decreased. In other words, x is directly proportional to y. X is directly proportional to y. So positive correlation means x is directly proportional to y, right? And if I get a negative correlation, something like this, minus 0.6, that means inversely proportional. Okay, so if I increase x, y will get decreased. If I decrease y, decrease x, y will get increased, right? So inverse relation. In that case, you'll get a negative value. But how much it is affected? So if I vary x, how much my y will be affected? 85%. That is what 0.85 means. Okay, I understand that because of positive. Yes. Okay, if you want to get correlation as 1, then the idea is both x and y should be same, right? The correlation of x and x should be 1. Otherwise, you will definitely won't get for two different variables, the correlation can never be 1. They cannot be exactly related. If that is the case, then both the variables are same. Is that your point, sir? Yeah. Okay, sir. Thank you for adding that. Thank you, sir. Yeah, so that is okay. But so the correlation of two different variables is what you're getting. So as you can see, we have got the correlation that can be got from using this cor function. That's all, data.cor. So as you can see, your experience and your experience, they are related by 1 because they are the same columns, right? Your experience and your experience and salary. Your experience and salary are related by 0.97 percentage, right? Which means if you increase your experience, salary will also be increased. That is why you got a positive correlation by an amount 97%. Right? So they are very or highly correlated. So it's very much, what I could say, it is very straightforward to use year experience as your X and salary as Y. This is a mathematical justification because they are interrelated by 0.97 times. If they are not related at all, you should not use that. You should not use that relationship. Is it okay? Okay, am I clear up to this? Am I clear up to finding out the relationship between different columns? Okay. Okay, sir. Okay, okay, ma'am. Thank you. Yes. So if you find it difficult to follow, please do let me know. Okay. Right. So after that, what I could say, let me assign X and Y. Oh, this is very important. I told you, the first day of the workshop that we are going to use NumPy to handle unstructured data, right? Raw data. So in some point, if you use data of year of experience, it should be a Pandas series, right? Pandas series. So you have to convert this to a NumPy array, somewhat an unstructured array. Okay, you have to convert this to an unstructured NumPy array. That can be done by using dot values. Okay, that can be done by using dot values. You can give only NumPy arrays to ML model. So that should be noted down. Some raw, you can give only raw data, not a particular column, right? So that is dot values. And y value also can be, y value should be salary. Or X must be your experience. If you have multiple columns for input, which can be multiple things, right? You can simply put like this, and you have to put comma and mention all those columns. Okay, I have to put comma and mention all those columns. Please note it down because for this example, I have only one column. So very well, I can have only one thing here. But for some other examples, you will definitely have multiple features, right? So to better use this. Okay, here I'll stick on to this. And this is a crucial step. After assigning X and Y, I have to split them, right? I have to split something for training and the rest of the data for testing. So that should be done. So in that case, I'm sorry, guys. In that case, what you could do is, let us say I have X and Y. Let us set like this. Let us say I use 80% for training and remaining 20% for testing. That is again a hyperparameter, fixing the train test ratio. So 80% for training and the remaining 20% for testing, right? So I have to split it into 4 different components, right? If I split like this, then this particular part will be used for training, right? I will call this X train. This particular part will be used for training again, right? So Y train, Y underscore train. So the training output and the training input, and this particular part will be X underscore test. I'll be using this X for testing, and I'll be using this Y for testing. So Y underscore test, right? Y underscore test, right? So I will split X and Y into 4 different components like this. Okay. Can you tell me which components will be used for training and which components will be used for testing? The part of the data set. That's okay. That means we have 4 components here, right? So which are those components will be used for training and X train and Y train. Am I right, sir? So while training, you have to pass both the input and output. A machine learning model is just going to learn the relation between X and Y. That means the straight line, the linear regression line. So you have to pass both X train and Y train while training. And for testing, not actually. You use only X tests, right? For when you test, say for example, I am going to attend the test, so I should get only the questions, right? Answers should be written by me actually. So machine learning model has to predict the Y values, so that should be compared with this actual Y test. That depends on your evaluation, right? So machine learning model should give me Y predicted. Okay, that should be compared with this Y test. That is actually your error. Okay. Yes, exactly, sir. Okay, am I making it clear? Yes, thank you, thank you. So this has to be kept in. So you will write a single code. You will write a single line of code which will actually split the entire data set into 4 different components: X train, X test, Y train, and Y test. So you have to assign like this, and the hyperparameter is 0.25. I have taken 75-25 split. So test size must be 0.25. Okay, test size must be 0.25. That you can fit here, and you can pass your X and Y, and you can pass your X and Y, right? So that should give you X train, X test, and Y train, Y test. After that, for linear regression alone, I have to reshape the array. Then only it will work. Otherwise, it won't work. That's why I taught this reshape specifically. Okay, so I have to reshape the array in such a way that -1 means number of rows is -1 means I don't know the number of row. You should take it by yourself. That is what I mean by -1. I'm saying the computer that I don't know the number of rows. I'm not interested in finding it, so you should take it by yourself. That is what I'm telling to the compiler. And 1 means I should have only one element in each row. This is the format you should follow. So I have to reshape the array as -1, 1, which means not normalization. Actually, I'm not normalizing the values. That is a different case. I'm manipulating the values. See, what I'm doing here is, let me give you an example. Let me print the output and show you. Let us have an array like this. All right. Can you tell me the shape of this array? The shape of this 1,5. Thank you. Is it 1,5? All right. It's a single dimensional array. So 1,5 means you have 2 dimensions, right? All right. Let it be. If I have an array like this, let us say if I put it like this, then it becomes 1,5. I have 1 row and 5 columns. This becomes 1,5. So this is 1,5. If I reshape it to -1, 1, -1 means I'm ignoring that argument. That's all. 1 means I should have one element in each column. That's all. Or in each row. In each row, I don't know the number of rows. In each row, I should have one element. That is what I mean by 1. So somehow you have to transform this array as this. Okay. So only this array will be accepted by the linear regression model. Is it okay, sir? Now it is not normalization, sir. That is different. Is it okay? Yes. Okay. Thank you. So you have to reshape it like this. So let me delete this code. It may confuse you later because I'm going to send this. Right. So we'll come back to here. It's a very long notebook. Actually, this code was written in live during the offline workshop what I conducted a month before September 30. So I wrote the code for 2 hours live, but I'm time being I have to show the written code, already written code. This may not give you the feel of doing something, but please bear since it is an online environment. And so I'm just calling the linear regression function here. So I have just reshaped and I got all the arrays, and now I got this linear regression model. So I'm just calling this linear regression model and I'm making it model 1. So model 1 is my instance, is my object, is my linear regression object. So from sklearn.linear model, you import linear regression. That's all. There is no need to write the algorithm by your own. There is no need to write gradient descent by your own. That can be done. Actually, that is very easy to do. You know the entire flow. Writing an algorithm is easy to do, but that is not necessary here. Okay. So I'm just calling that linear regression and I'm assigning it to one instance, model 1. After that, I am using model 1.fit. In the entire world of sklearn, sir. That's again a library. So that library will have support for all these machine learning model. Scikit-learn it stands for. Okay, so you have linear regression, logistic regression, K-NN regression. You have a lot of machine learning algorithms sitting inside that library. You can directly use it. Okay, sir. Yeah. Okay, sir. Done. So now fit in the world of machine learning and deep learning, whenever I say fit, it means I'm training. Okay, fitting means fitting the line of best fit. That's what I mean by training, right? So this single line will be enough to do the training. Okay, so I will pass X train and Y train for training. I should not pass X test. I should pass X train and Y train for training. So after training the model, or once I have trained the model, I can predict the model. Okay, I can predict the value for that model. So model 1 dot predict. Now I should pass only X test. The explanation for this have been given before. So I can use this predict function to predict the values. So I can pass only the inputs. The outputs, whatever I'm getting, I'm storing it in Y predicted. Outputs, whatever I'm getting, I'm storing it in Y predicted. Right? And I'm getting the Y predicted values here. These are my predicted values. Right? And these are my actual values. Y test are my actual values. As you can see, they are somewhat closer, and you can see larger differences. This is because I have a very less number of data. I have only 30 samples, which won't be enough for the model, right? So I got somewhat closer values, and I can take difference between them, difference between Y predicted and Y test. That should evaluate my model. That error should be very, very less, right? So I can take the error. That can be done by simply calling mean squared error. From sklearn.metrics, you can simply call mean squared error to get the error. And you can take the square root. That becomes the RMSE. That means root mean squared error. Okay, root mean squared error. You ignore this. Then if you want to visualize the line of best fit, this is what it looks like. So as you can see, many points are lying closer to the line. So this is the line of best fit I got for my linear regression problem, right? And you can even try with polynomial regression as well. In that case, this is my polynomial features, and this is my polynomial curve, and you can try with KNN regressor as well. That is there. So there are a lot to discuss here: decision tree regressor, support vector regressor, everything. Probably we'll do that in C-equal. That is part 2 of this workshop. I think now I'm done. I have 10 more minutes left out. I leave this for Q&A, question answer session, because for the 3 days we have to, for the last 10 minutes, we can summarize and discuss what are all the things that we have done for the entire 3 days workshop. I'll send you this notebook where you can work on it separately. So I'm open to discussions now. We can post your questions in the chat box for another 10 minutes, and we'll wind up by 8:50. I hope this workshop is useful to you. If you have any questions on machine learning, what is exactly overfitting? Okay, I'll answer this question. Ishit sir, please. Okay. All right. Overfitting, to be, if I could give you a real world example, mugging up the content is what we mean by overfitting. So why is that a problem? If you mug up some contents, the questions, whatever you have mugged up, for that you know the answer. But when you go to the examination, you won't know the answer for the question which has not been seen before, which has not been seen by you before. That is what exactly overfitting is all about. Let us assume like this. If I have a data point, something like this, right? Instead of fitting a straight line, what if I fit a curve like this? What if I fit a curve like this to cover the entire data points? The problem here is, for a straight line, I have a standard equation like y equal to mx plus c. So I will be able to extend that particular line. Okay. But if I fit a curve like this, if I try to cover all the data points, that means if I overfit, if I try to cover all the data points, if I overfit the data, I will make the best and best of the fit. That means to overfit. In that case, I won't get an equation like this. I won't be able to extend that particular curve. I won't be able to regress. I don't know in what way I should regress it, right? In what way I should, in which direction I should extend it. I don't know that, right? Because this is already random fitted model. An overfitted ML model will perform well on your training data because it is fit to all the points in your training data, but it won't perform well on the testing data. It won't perform well on the unseen data because it won't be able to regress well. It won't be able to extend or extrapolate well. Is it okay? Is it okay, sir? KD stands for kernel density estimate, ma'am. Great that you have noted it down. I'll show you. Let me show you that. Yes. So by making KD equal to true, along with this histogram plot, I will get this probability density function too. Okay. I will get this probability density function too. The idea is I will get both histogram plots and the distribution plot in the same plot. So if I make KD as false, by default it is false only. I won't get this plot. I will get only histogram. Is it okay, ma'am? Yeah, okay, ma'am. Thank you. Any other questions? A very, very difficult question to answer, sir, actually. Yes, so what I showed you in the slides is statistics becomes ML, right? See, ML is where you use statistical procedures to learn the data, right? So that ML is actually a potential application of statistics. That should be the right way to say it. Statistics has a wide variety of application. ML actually uses statistics in a much intelligent manner. So it has kind of intelligence. Yeah, that is also a good way to go through any library. It is up to your wish because anyway you're going to put that in your own research article or paper. So anything that is comfortable for you. Something related to R programming, right? When it comes to table AU, so on so. I don't know it, to be very honest. Yeah, you can use it, man. You can use table AU, and I'll show you some methods also. There is no need to write this code. I'll send you some methods in group, which is a GUI kind of structure where you can simply pick the variables and plot it and see. Pandas has support for that. There is no need to write the code by from scratch. You can select those columns and you can directly get into plotting. That is possible. Any other questions?
Sujit, can I have 2 minutes? Katya
Yes,
ma'am
ma'am.
here.
Sure.
Sorry,
ma'am,
I'm
sure.
outside right now.
Okay.
Hi all. Actually, I'll keep my video off for a moment.
Okay.
A team.
Hello. Able to hear me, ma?
Yes, ma'am. You are very much audible.
Yes,
ma'am.
yes. Participants, any feedback you would like to say before get into it? Anusha, can you share the screen? Anusha?
Yes, ma'am. I'll share the screen.
Yeah. Sujit, you stop share the screen. Anu will share.
Yes, ma'am. I stopped sharing it actually.
Fine.
I stopped it.
Friends, I would like to say one input from my end. We have a feedback form here. I'm going to give you an Inspire ID. Okay, that I'll be sharing in another half an hour time since I'm outside. Okay, I'll be sharing your unique ID in a Excel sheet. Okay, that you can put. I'm just giving a demo here. How your Excel ID, like your unique ID will be. Anu, you give a demo on that. You just talk to them. You just explain like how they can fill the data.
First, you have to fill the Inspire ID, and then the name, organization, email, mobile number, place, state, and you can give the comments here. And then if you submit this, you'll be receiving your certificate through your mail. That's what the procedure is.
Ma'am, are you there? Can I take over, or you want to share some points?
Anu, you please give 9-8.
I have a course on SVM, if I'm not wrong. PCA, definitely not to teach. Definitely, I do on that. But SVM, the content is not that much big for a separate course, actually. I cannot make a standalone course on SVM. PCA, maybe we can try dimensional reduction techniques. Cannot make standalone courses. Yes, ma'am. You can take my number from the WhatsApp group. I'll give the number. I'll share the number in the chat box itself. And contact me anytime. Thank you. So classifiers performance is not solely based on accuracy, but also on certain time. What are the limitations of classifications? See, to evaluate classifiers performance, you have to use something called as confusion matrix, right? And it depends on various factors: precision, recall, accuracy. You have a lot of factors, right? So you have to look around on all these factors, and all these factors have trade-offs. That means if you want to achieve high precision, your recall will go down. You have to sacrifice on recall. And if you want to achieve high accuracy, in that case also your recall will go down. But you have to understand what are these terms. That we will try to cover in the second part. Okay.
Sujit, 1 second.
Yes,
Let me convey one message. Sujit?
Sure, ma'am. Go on.
Team, actually, the feedback link as well as your unique ID will be shared through mail as well as in WhatsApp after an hour. Okay, I'll share it with you. No worries. Immediately while you fill it up, you will get your certificate through mail. No worries. Okay. Anybody would like to share any feedback, please? You can share your verbal or written feedback.
I met to do, ma'am. I'll try doing it actually for PCA. Think I'm focusing much on the core part, the electronics and communication part. I teach, better than this. So yeah, I'll try doing some courses on data sciences as well. That I'll do for sure. Anybody wants to share your feedback, or if any questions, you can keep on posting the questions on the chat box. I'll be happy to answer them. But meanwhile, if anyone has any feedback, you can give a verbal feedback on consolidated feedback on all the 3 days. I would be really happy, gently.
As
What
a
kind of-
token of your gratitude, can everybody clap for Sujita? Raise your hands for the 3 days fabulous workshop. Thank you so much. Yes. Good. Super,
Humbled.
Sujit, for your wonderful session. Thank you so much. And thank you, participants, for your support. As promised, within an hour, you will be getting all the details. Okay? Thank you. Good night. I'm leaving as Sujit can continue. Thank you, Sujit.
Sure, ma'am. I'll just continue for another 5 minutes. I have some more questions to answer. Thank you, and thank you. Very humbled to see the responses I'm getting here. Digital claps. Thank you so much. So I have some more questions. I'll make sure I'll cover everything. So how do I know the rule setup for that? The classification rule, whatever, which is see, you try different classification algorithm. Okay. You get the results and you try to find out the confusion matrix. So confusion matrix is the fundamental evaluation metric, right? So you try to find out the confusion matrix for that. From that matrix, you can derive accuracy, precision, and recall. Whichever gives you the most, the better accuracy, that we can fix it. You can say that that model performs well on this data set. Could you provide coding random forests and other ML deep learning? The code is available on the net, right? This is pretty straightforward. Instead of linear regression, you can go to the documentation, and random forest can be implemented by a single line. Okay, that should not be a problem, sir. If you want any specific code, maybe I can try it out. Definitely, I'll do it, ma'am. I'll share my notebooks. Not at all. I'll share one empty notebook which will have some questions. You can try it on your own. That is that. I don't want to waste time. I could have given the notebook by now before a while itself, but I don't want to waste the time. So I'm okay. Thank you, gentlemen. Any other questions? Thank you, doctor. Thank you. I think I should have one more session. Yes, ma'am. Yeah, I'm packed for the next month. I have some other classes in embedded systems, IoT, VLSI design. I'm packed completely for the January. Maybe in February or March, we will plan part 2. Sure, ma'am. Thank you. Inspire is also packed parallelly because Inspire also conducts a lot of workshops in the month of January, if I'm not wrong. No, we do second derivation. I mean, we do second the second derivative, right? Yeah, we do second differentiate twice to find out whether the optimal point we got from the first derivative is attaining local minima or local maxima, right? If the second derivative gives you a value which is negative, means the critical point, the curve attains local maxima, right? If the second derivative gives you the value as positive, means curve will attain local minima. Are you taking any Python classes? I took 2 years before. Not now, actually. I have Python course that you can see, but yeah, that is there in Udemy. I'll share you the link. I'll share the link of all my courses. AWS Cloud Platform. Yeah, why does it come here? Actually, yeah, I'll do it, sir. Definitely do it. I'll do it. To be honest, it's a promotion for me as well, right? So I'll do it for sure. Python, yeah, I'll do it, sir. I'll do it, ma'am. Thank you. I'll do it. I'll share the details for Python course. All session. Thank you. Thank you, sir. It's really a good review. Thank you. Okay. So, any other questions? Thank you, sir. I think you are very interactive, sir. Thank you so much. I must thank you for being very, very interactive. You gave me a lot of pointers as well. At times I forgot, some things, and you gave me a lot of pointers to actually go back and get those contents. Thank you so much, sir. I think I'm not seeing any questions anymore. So it's good to go now. Yeah, thank you, ma'am. Thank you so much. Thank you. Yes. So my areas of interest, that means my research interests are analog VLSI, analog circuit design, deep learning, and machine learning. So I should be able to help you in all these areas. Yes, sure, sir. Sure, definitely, sir. That's all. I'm not seeing any more questions. Thank you. Thank you, people. Thank you. Yeah, so honored and humbled to be here. Thank you. Bye. Good night.
Yeah, thank you, Sujit.
Thank you.
And thank you, participants, for your cooperation. And as ma'am said, we'll be sharing the unique Inspire ID through mail, and you'll be receiving the feedback link also within 1 hour. Thank you for your active participation. Thank you.